In the gray stillness of early spring, before any leaf has opened, a birch tree is already working. Birch buds have been recorded in European pharmacopoeias since the 16th century, listed alongside compounds that cost fortunes to synthesize today. A 2014 study published in the Journal of Ethnopharmacology documented over 40 distinct bioactive compounds in Betula pendula buds, including Betulin, luteolin, and hyperoside. Russian military field manuals from the Second World War listed birch bud preparations among approved topical treatments for wound care, carried by frontline medics across the Eastern Front. This tree grows on every northern hillside, in every temperate forest, in every abandoned field from Siberia to Scandinavia. It is the most common tree in Russia. It is arguably the most overlooked medicinal plant in the northern world. The system had every reason to ignore it. You cannot file a patent on a birch. You cannot build a monopoly around a tree that seeds itself into gravel. And yet, the chemistry inside those small, resinous buds rivals compounds that fill hospital formularies. Researchers who studied it called the results unexpected. The pharmaceutical industry called them inconvenient. And somewhere in that resinous chemistry, in those tight, wax-sealed scales harvested before the first leaf breaks, lies a discovery so quietly radical that it never made the news. The outer bark of the birch tree is white for a reason. That whiteness is betulin, a pentacyclic triterpene synthesized as structural armor against UV radiation and microbial attack. Birch buds concentrate betulin and its metabolic derivative betulinic acid in quantities far exceeding the bark. By the 1990s, researchers at the National Cancer Institute identified betulinic acid as selectively cytotoxic against melanoma cells. The compound attacked tumor cells while leaving healthy tissue intact. That specificity is rare in pharmacology. It is almost unheard of in a substance that grows freely on every northern hillside. The problem was immediate and commercial. Betulinic acid could not be patented in its natural form. No patent means no monopoly. No monopoly means no return on investment. The research slowed. The funding dried up. The birch continued to grow. Long before any laboratory existed, Siberian and Scandinavian healers understood this tree in a different language. The Khanty people of western Siberia collected birch buds each spring as a seasonal ritual, a timed harvest at precise bud stages, not a casual act. Norse medical texts from the 12th century reference birch preparations for skin conditions and joint inflammation. In Russian folk medicine, birch bud preparations were applied topically for wounds, rashes, and swollen joints, practices documented by ethnobotanist Nikolai Annenkov in his 1878 Botanical Dictionary. These were not superstitions. They were observations refined across generations. Medieval European herbalists called the birch arbor vitae, the tree of life. Not metaphorically. Practically. The resinous compounds in the buds are antifungal, antibacterial, and anti-inflammatory by modern chemical definition. The ancestors simply described what they witnessed. The laboratory arrived centuries later and confirmed it. History does not always move forward. Sometimes it circles back to what was always true. A birch bud is a compression of the tree's entire biochemical strategy. The resin coating the bud scales contains flavonoids, luteolin, quercetin, and hyperoside among them. These are not passive molecules. Quercetin alone has been studied in over 10,000 published papers for its role in modulating inflammatory pathways. The buds also contain essential oils, predominantly cineol and alpha-pinene, compounds shared with eucalyptus and pine preparations used across northern European traditional medicine. Betulin constitutes up to 30% of the dry weight of outer birch bark and accumulates in concentrated form within the developing bud tissue. This density is the reason herbalists historically harvested buds specifically, not leaves, not bark, not catkins. The bud is the tree's most metabolically active tissue in late winter. It is where energy is stored and where defense compounds are densest. Nature does not waste resources. Everything in that resin has a function. Modern phytochemistry has confirmed most of them. The full picture is still being mapped. The birch tree grows across roughly 40% of the northern hemisphere's forested land. It requires no cultivation, no irrigation, no pesticide. It regenerates aggressively after cutting. A pioneer species that colonizes disturbed land faster than almost any other tree. From an industrial perspective, this abundance is the problem. A medicine that grows everywhere requires no patent, and needs no factory cannot be monetized at scale. The pharmaceutical model is built on scarcity, synthetic molecules, controlled synthesis, proprietary formulas. The birch offers the opposite. It offers radical availability. Traditional medicine systems across Russia, Finland, and the Baltic states maintained detailed knowledge of birch bud applications for centuries. That knowledge was never translated into clinical trials at the scale it deserved. Not because it failed, because there was no financial architecture to support it. The absence of research is not evidence of absence. It is evidence of economics. The studies that did emerge painted a consistent picture. A 2013 paper in Phytomedicine confirmed significant anti-inflammatory activity in birch bud extracts, linked specifically to betulin and luteolin content. Research from the University of Helsinki documented strong antimicrobial properties in Betula pendula bud resin against multiple bacterial strains. A 2019 review in Molecules catalogued the antioxidant capacity of birch flavonoids as comparable to well-funded botanical extracts like green tea and maritime pine bark. These are not fringe results. They appear in peer-reviewed journals. They replicate findings from traditional use with molecular precision. The anti-inflammatory pathway alone explains centuries of topical application for joint pain and skin conditions. The antimicrobial data explains the wound care traditions documented in wartime medical records. Science did not discover what birch buds could do. Science confirmed what northern peoples had practiced for 1,000 years. The delay was not scientific. It was political. It was economic. The birch bud has a precise harvest window that lasts only days. Experienced collectors in Siberia and Scandinavia watched for the moment when buds were fully swollen, but not yet cracked open, the point of maximum resin density. Once the leaf begins to emerge, volatile compounds dissipate rapidly. The window closes. The chemistry changes. This specificity is itself a kind of knowledge, earned across generations of observation, not written in any manual. Traditional calendars in northern Russia tied birch bud harvest to snowmelt timing, not calendar dates. The tree set its own clock. The collector followed. This relationship between human knowledge and plant phenology was not incidental. It was the foundation of an entire medicinal system, one that required no laboratory, no supply chain, no prescription. Only attention, only patience, only the willingness to look at a common tree and see what it actually offers. The birch has outlasted every empire that grew beneath it. It grew through the collapse of the Roman trade routes that once carried exotic medicinals across the continent. It grew through the Industrial Revolution that paved over the meadows where healers once walked. It grows now in the margins of highways, in the cracks of post-industrial land, in the forests that returned after Soviet collective farms were abandoned. The knowledge of its buds has survived too. In ethnobotanical records, in pharmacopoeia footnotes, in the memory of rural communities across northern Eurasia. A new generation of researchers is returning to these records, not with nostalgia, with instruments. The birch does not need rehabilitation. It never disappeared. Only our attention did. The most radical act in modern botany may simply be to look up at the white-barked tree on the edge of every field and remember what it contains. It cannot be patented. It cannot be owned. It was always there.